In this video, we're going to go over the 4-click method to creating an anomaly detection algorithm. So we're going to go over some of the basics of the project section, but we're going to touch on some of the more advanced settings in a later video. So here, again, we can add a project from the beginning of this home screen, or we can go ahead and click into the project screen. So again, the projects is just a container, a folder that would house all of the models we're going to create, either it being a clustering algorithm, classification, regression modeling. This is where it's all going to be housed. So we can also create a project from the dataset directly. And I'll go ahead and show you that if we come here to the dataset, we can use the demo compressor and create a dataset, and it'll bring us back to or create a project, and it'll bring us back to that project screen. So I'll go ahead and manually do it here. Create project. Let's do test2 project. And the dataset we're going to use is that test2 data. Now, when you hit create, your project will always end up at the bottom of the screen, but we can go ahead and refresh this page and it'll resort it alphabetically. So here, we're going to go ahead and create that 4-click anomaly detection model. And I'm going to go ahead and give it that name, 4-click model. And again, this is going to be anomaly detection. So first click is to name the actual algorithm itself. The analysis, we're going to use all of the data tags associated to this data set. And again, what we had before is that we could do the advanced filtering on the data set to make sure that this system is online or offline, or if you want to filter out a certain set point, things of that nature. So we can come here and add or select rules. So here I'm going to go ahead and have motor current greater than or equal to 10. I'm going to add that as our on condition for this model. Save this filter and apply it to the data set. Also, we have the option to determine which tags we want to use to create this model. I can unselect all of these tags and only select maybe 1 or 2, maybe 3 or 4 tags. And we also have a save option. This save option is going to be for allowing us to quickly determine or save the list of tags that we've had previously. So I'm going to go ahead and select option 1 in here, save it. And now you can see we have this green button that has appeared. It's the load setting. So I'll go ahead and include all of the tags. I can also hit this, select option 1, and now you can see it's only saved those tags that we selected previously. So for this, we want to use all the tags within the data set, and we're going to go ahead and do our second click, which is going to be this next arrow. So for anomaly detection, we typically use a clustering algorithm. We can use a classification in some cases, but for the majority of our projects, we use clustering algorithms for this anomaly detection. As you can see, we have an auto select feature that will go through this list of algorithms for clustering type algorithms. And in the other video, we're going to go over more of the different type of algorithms that we can use, and then the actual algorithm names within those types. And we'll also go a little bit more into what this advanced setting can do. But this will be the third click. And again, if we had multiple versions of this data, the first 6 months, next 6 months, 2 years ago, whatever it may be, we can add those versions to this model. And I'll go ahead and hit play. So 4 clicks, and we're using that data set. We're using that data set that we brought in, test2, to create an anomaly detection algorithm. So we're going to go ahead, give this a little bit of time so that it's able to create the model. And then we have the option to view this data set, use it in an offline predictor, download it as a zip file so we can manually take that data and upload it to a SDC or a smart data collector, delete it from this machine learning platform, deploy it to a SDC that has a connection to the SORBA server, or undeploy it from a system that's connected to the SORBA server. There is also this retrain model button that if we have more versions of this data set, we can simply hit retrain and select which version of the data set we want to retrain on to determine how well this model would be able to find critical failures or issues or anomalies within that new data set. On the left hand side here, you can see we have the name of the model, the version number of this model itself, the date that it was created, the initial system was created, and then the data set that's attached to this model. Okay, now we see that the actual model is ready for viewing. So we'll go ahead and select view. We can see on this side of the screen, we have some of the model settings from performance, preprocessing, parameters, anomaly detection, the acceptance rates, and so forth. Here we see that the anomaly that was chosen from that list of clustering algorithms to be the mean shift. Here in the view sections, you can see that we have three separate tabs: anomaly detection, prediction, and probability. Here we have the option to synchronize our graph, so we can look at the actual raw data as compared to anomaly detection. So we can see here, we have the anomaly score in a percent format from 0 to 100. We have the actual anomaly detection, the anomaly detection boolean. Now with the sync graph options, what we can do is highlight this anomaly and compare it against the raw value, and then double click to unzoom. Here we have all the raw data that we can uncheck and check whichever tags that we want to actually look at and compare against. In the prediction tab, we have the prediction model. And in the probability tag, we have the 0 to 1 probability. So we're looking at all the different cluster values here, and ability to filter them out also. Now we have a model that was created on that 4-click method. And what we can do now is go back to projects, go to our test2 project, look at the model itself, and deploy the model to an SDC if we see fit. Now in essence, we have completed the 4-click approach to create our first anomaly detection model.